Have you ever just stopped and wondered how it all fits together? I mean, everything. From the tiniest invisible particles to, the entire planet we're standing on. Well, today we're going on a pretty epic journey to map out the very structure of reality itself.
It really does seem kind of impossible, right? How does a whole universe of simple, non-living stuff somehow, over billions of years, organize itself into something as ridiculously complex and alive and aware as a person? This isn't just some late-night philosophical question, though. It's a scientific one. And we're going to climb the ladder step by step to find the answer.
Okay, so before we start climbing, we need to get our heads around two basic rules. These are the fundamental principles that let the universe build itself up, turning absolute simplicity into the jaw-dropping complexity we see all around us.
So first up, we've got complexity. Now, this isn't just about having a ton of stuff. A giant pile of sand has a lot of parts, but it's not complex. A complex system is one where all the different parts are constantly interacting with each other, creating dynamic and, frankly, often unpredictable results. Think of the difference between a pile of bricks and a bustling city. That's complexity.
And the second rule, this is the secret sauce. This is emergence. Emergence is what happens when a group of things, just by interacting, creates a totally new property that none of the individual parts had by themselves. It's kind of like the universe's greatest magic trick. Let me give you the perfect example of this. Think about a single molecule of H2O, just one. On its own, that molecule has zero concept of wetness. It's just not a thing. It has certain properties, sure, like polarity, but wet isn't one of them. It's a weird thought, but it's so important.
See, wetness is a classic emergent property. It only shows up when you get trillions of those water molecules all interacting together in the right way. The group literally becomes more than the sum of its parts. This simple idea, right here, is the engine that drives all of creation.
All right, with those two rules in our back pocket, let's start our climb. We're going all the way down to the very bottom, into the non-living world of physics and chemistry. This is where we find the universe's most basic Lego bricks.
So it all starts with these fundamental particles, things like quarks. Get a few of them together, and you get the emergence of protons and neutrons. Those then combine to form atoms, all the elements on the periodic table. Then, atoms link up to create molecules. And finally, those molecules chain together into these enormous complex structures, like DNA, the actual blueprint for life. Every single step is a new level of complexity, with new properties emerging along the way.
And now, we take the great leap. We're moving from the non-living to the biological. This is the incredible moment where chemistry crosses a threshold and the truly staggering property of life itself emerges for the very first time.
So those huge macromolecules, like DNA, they start organizing themselves into little specialized parts called organelles. Those organelles then come together to form the first cell, the basic unit of all life. From there, cells team up to form tissues. Tissues build organs, like your heart or your brain. Those organs work together in systems, and all of those systems combine to form one complete independent organism, you.
And just look at the new powers that get unlocked at each level. A single cell suddenly has metabolism and can replicate itself. A tissue, like a muscle, gains coordinated function. It can contract. An organ, like the brain, well, that allows for maybe the most mysterious emergent property of them all, conscious thought. And finally, the whole organism gets independent survival. None of these abilities existed at the level just below them.
But hold on, the hierarchy doesn't stop with you. We're not at the top of the ladder yet. Now we have to zoom out and see how organisms, including us, create even bigger, more complicated systems just by interacting with each other.
Right, so individuals form a population. Different populations interacting in one place create a community. That community, plus its physical environment, forms an ecosystem with its own emergent properties like nutrient cycles. Groups of ecosystems become massive biomes like a rainforest or a desert. And finally, you put all of that together and you get the biosphere, the single, gigantic, interconnected web of all life on Earth.
And layered on top of all of that, we humans have created this uniquely powerful level of complexity. Human society gives rise to totally new emergent things that aren't even physical. Abstract ideas like laws, shared realities like culture, and these massive networks of collective knowledge like science or the internet.
So, this brings us right up to the present day, the bleeding edge of the hierarchy. We're looking at the levels of organization that are literally emerging right now, and even speculating about what might lie in our future.
I mean, we are right now witnessing the birth of a technological level. Think about global networks, AI, algorithms, systems that can learn and optimize themselves. And beyond that? Well, beyond that is the truly theoretical, a transcendental level. A post-singularity intelligence that could maybe even manipulate the fundamental laws of physics. Yeah, it's the stuff of science fiction, for sure, but it's a totally logical next step in the hierarchy.
So, we end up right back where we started, but now we see it differently. The journey from a simple quark to you wasn't just some cosmic accident. It was the inevitable result of complexity and emergence playing out over billions of years. It proves the universe is basically a machine for generating novelty. And that leaves us with one final massive question. If the universe truly is capable of creating infinite new things, what level of complexity will emerge next?